Good morning. Let us study today how to determine the ground state term circles. In the previous class, we have studied for P2 electronic configuration. There are three terms. There are how many terms? There are three spectroscopic terms we have obtained from the 15 possible different electronic configurations. P3, D1, S1. Okay, these three states. Now, there are three simple rules to obtain the ground state. What is ground state? What are excited states? From the three states, which one is the ground state? Which one is the excited state? Which one is the second excited state? There are three simple rules to obtain the ground state and the excited states. The first rule is that choose according to Hund's rule of maximum multiplicity. Maximum S value is the most stable state. According to Hund's rule, the maximum S value is the most stable spectroscopic state, most stable term. The most stable term is the ground state. The most stable term is the ground state. Now let us apply the first rule to P2 configuration. Now you see which one has the maximum spin multiplicity. This is 2s plus 1. See, this is the expression for time symbol, and this is the maximum spin multiplicity. The maximum spin multiplicity P3. This is the state with the maximum S value. So this is the most stable state, and this is the ground state. So for carbon I have shown P3. This is the most stable state. Right. Next, let us apply the next rule to find the first excited state and second excited state. For given S value is the most important. See, always S value. Choose the maximum S value. Then choose the next maximum S value. Next maximum S value is 1. Okay, so 1, 1. Both are having for given S value. Then choose the highest L value. From the two, both have S equal to 1. Okay. So choose the highest L value. L equal to 0, S state. L equal to 1, P state. L equal to 2, D state. L equal to 2. This is the highest L value. Therefore, this is the first excited state, D1. This is the first excited state, D1. Right. Then obviously, this is the second excited state. According to rule 2, this is the first excited state, and this is the choose the highest L value as the next excited state. Okay, for given, now we have arranged the states in the increasing order of energy. See, this is the most stable state with the lowest energy. This is the S1 is the highest energy state, highest energy excited state. Okay, next, so P3 is the ground state, S equal to 1. Okay, S equal to 1. And next state, by applying this D1, for given S value, choose the highest, therefore this is the. So I have drawn here. D1 is the first excited state, and S1 is the second excited state. Next, for given SL value, for example, for given SL values, less than half filled means smallest. Choose the smallest J value. More than half filled means if the state is more than half filled, then the highest J value is the ground state. Then the highest J value is the ground state. For example, what is less than half filled? Here, P2, P1. See, are not half filled, less than half filled. Now here you see more than half filled, P5, P4, they are more than half filled. Okay, so for given SL values, less than half filled means smallest J value. For P2 configuration, okay, let us take the ground state P3. And P3 L equal to J equal to L plus S. Okay, L equal to 1. Okay, L equal to 1. and S equal to 1. It has 2s, S equal to 1, 2s plus 1 equal to 3. S equal to 1, therefore J equal to, J is due to the coupling of resultant orbital angular momentum and the resultant spin quantum number. Spin angular momentum quantum number, that is equal to 2. Therefore J can have values 0, 1, 2. Now J can be 0, for example 0, 1, 2, 0, 1, 2. Now which is the ground state? Which is the ground state? So this is the, let us apply the third rule again. We will see for given SL values, all the states have SL same, but J value only different. J value only different. So J value, depending upon the J value, it is the ground state. It will decide the ground state, excited state. J value equal to 0, 1, 2, 3. There are 3 states. Therefore, for given SL values, less than half L, see P2 is less than half L, then smallest J value is the ground state. Smallest J value. So J value 0 is the ground state. This is the ground state. See, if you look at oxygen, as let us see hole formulation. What is hole formulation? For example, P1 is less than half L, P5 is more than half L. Okay. Now number of unpaired electron, when the number of unpaired electron, in this case number of unpaired electron is 1. Here it is filled, number of holes, number of unpaired electron is 1, is equal to number of holes equal to 1. Number of hole formation. Therefore P1 and P5, we have earlier seen P1 and P5 have the same number of microstates, therefore they have same terms, therefore they have same spectroscopic states. For example, P2 and P4, there are 2 unpaired electrons, and here we see there are 2 holes. This is filled, here one hole and here one hole. There are 2 holes. P2, P4. Therefore, P2 and P4, number of unpaired electron is 2, number of holes 2. So they have same number of microstates, and therefore they have same spectroscopic states. P3, D1, S1. Okay. Now this is actually 2. Okay. Now there are both have that, but if you look at here, according for a given SL values, okay, again for oxygen, this is the ground state, but this is more than half L. So when P4 is more than half L, then for more than half L, highest J value. Therefore, for oxygen, P2, this is the reverse. P2 3, P1 3 is the order of states in the increasing order of energy. So this is the ground state because the highest J value is the ground state for more than half L for a given SL values. So we have seen what are hole formalism. Now D1, similarly D1, D2, D3, D5, D1 number of unpaired electron is 1, D9 one hole. Therefore D1 and D9 have the same number of terms, same number of microstates, have same number of states. Similarly D2 and D8, D3 and D7, and here number of unpaired electron is 2, D8 number of holes is 2. Okay, so they are related. Once you know the D1, for example D1 state, D9 are also same. So you can simply write, for example, P1, P4, they have the same terms. Okay, let us now derive the ground state terms for P1, D2, any configuration, D10 or P6. Just to follow the simple rules. Here I have given, for example, this is boron P1, and the electronic configuration Z equal to 5, 1s2, 2s2, 2p1. The core electrons the core completely filled shells does not contribute to the term symbol. Therefore, let us take P1, one electron with the up spin, Therefore, ml value plus 1, 0, minus 1. Therefore, ml, total ml value is only 1 electron, therefore 1. Okay. And ms value, only 1 electron, therefore only 1 electron, ms value 1 by 2. Okay. Right. Now, therefore, L equal to 1. L equal to 1 is P term. So, L equal to 1. L equal to 1 is P term. And 2s plus 1. 2 in 2s plus 1 is the spin multiplicity. Therefore, 2 into 1 by 2 plus 1, it will be doublet state. It will be doublet state. Okay. So, P doublet state is the ground state term symbol. You will be given an atom. You first write down the electronic configuration. From the electronic configuration, you calculate the sum of ml, sum of ms to give ml, and ms you will get the L plus L value and 2s plus 1 value and the J value. Okay, now for example D2. For D2, what is the ground state? What is the ground state term symbol for D2 electronic configuration? Therefore, plus 2 plus 1 orbital angular momentum quantum number plus 1 0 minus 1 2. There are 2 unpaired electrons. Therefore, ml value equal to plus 1 plus 2 summation of small ml, summation of ml plus 2 plus 1 plus 3, and summation of s 1 by 2 s equal to ms equal to s equal to 1. Therefore, 2s plus 1 equal to 2s plus 1 equal to 2 into 1 plus 1 equal to 3. Therefore, F3 is the ground state term symbol. F3 is the ground state term symbol. For example, D10. Similarly, if you are asked to D10, what is the ground state? What is the ground state term symbol? So let us apply Hund's rule. You pair up after all the available orbitals are singly occupied. Okay. So here ml plus 2 plus 1, this is plus 2 minus 2 0, so 0. Therefore, ml equal to 0 and ms equal to 0. Okay, because plus or minus or plus or 0. Therefore, L equal to 0, S state and 2s plus 1, 2s by s equal to 0, therefore s 1. This is the ground state term symbol for D10 electronic configuration. Okay. Similarly, you will be asked to, you will be given atomic number, or you will be given the element, and you are asked to find what is the ground state term symbol. Let us apply the formula. So once you understand the fundamentals, you will be able to answer all the questions asked in the competitive examinations. Thank you for watching.